Assalamualaikum. We are from Group 3. So today we will present about heat radiation. My name is Aminuddin bin Nur Azdi. My metric ID is MA18141. So for abstract, this experiment focuses on radiation. There are several ways in which a body releases energy and it flows through a form or region of another organism which consumes it. A part of the experiment's purpose was to investigate radiation's properties and behavior. We are continually exposed to a range of radiation sources on planet Earth. For your information, Earth receives solar energy every 8.3 minutes. Photosynthesis uses chlorophyll, for example, to turn sunlight into chemical energy. Introduction. Radiation heat transfer is concerned with the exchange of thermal radiation energy between two or more bodies. Between two bodies, heat can travel without the use of a medium. Photons are energy particles that travel in random directions. Radiated photons can be absorbed, reflected, or transmitted when they reach another surface. There are three ways in which heat may be spread. First, conduction, convection, and radiation. Conduction and convection required medium to transfer from higher temperature region to lower temperature. Radiation, on the other hand, doesn't need anything to transmit. Energy may be transferred through electromagnetic wave using radiation. For example, heat from the sun, it is a type of radiation which is classified as thermal radiation. For example, heat from the sun, it is a type of radiation which is classified as thermal radiation. That's all from me. Thank you.
Assalamualaikum. My name is Nur Fahana binti Muzani. My metric number is MA1013. For the experiment, I will explain about the objective and the basic equation. For the objective, to study the effect of the distance of heat and radiometer and the reading of radiometer, to study the relationship of aperture opening and the radiometer reading, and lastly, to demonstrate that the intensity of radiation on a surface is inversely related to the square of the surface distance from the radiation sources. Next is a basic equation. For this experiment, the equation is used is alpha plus P plus T equal to 1, which is alpha, absorptance, fraction of the incident radiation observed, reflected, fraction of the incident radiation reflected, and T is a transmittance, which is fraction of the incident radiation transmitted. Other than that, there are several equations that used in this experiment. Firstly, the Stefan-Boltzmann law. The equation is QB equal to sigma Ts power of 4 minus Ts T square power of 4. QB, which is energy radiated by a black body per unit area. Sigma, the Stefan-Boltzmann constant. Ts, surface temperature of the heated plate. T square, surrounding temperature including the radiometer. The radiometer value will be connected to the radiation emitted by the plate via a constant factor F. F equal to QR divided by QB. QR, which is radiation received by the radiometer. F is a view factor. Next is a radiation intensity. The radiation received by the radiometer is linked directly to the radiation supplied by the source via the view factor F, which is defined as the proportion of energy emitted in unit time by one surface intercepted by another. We have equation for in this situation, which is QB equal to F times sigma times Ts power of 4 minus T square power of 4. Next, view factor relation. The calculation of n square view factors are required for the radiation analysis on enclosure consisting of n surface. To be able to analyze view factor, four basic relationships must be established. Next equation is emissivity of radiating surface, which is QB equal to E times F times sigma times Ts power of 4 equal minus Ta power of 4, where E is the emissivity of the radiating surface and for a black body, E equal to 1. The view vector will change if a black plate is placed on an appropriate support between the radiating surface and the radiometer. and the plate is square rather than circular. In this situation, the emissivity of the plate position between the heat source and the radiometer equals E equal to R divided by sigma times F times Ts power of 4 minus Ta power of 4. Next is a radiating energy. In the basic example, when a small hot surface at temperature Ta and with an area of AA is surrounded by a large cold surface at temperature Tb and with an area of AB, equation below give the radiative energy exchange QAB between two black surfaces. The equation is QAB equal to sigma times AA times FAB times Ta power of 4 minus Tb power of 4. This simple equation may be used to calculate the radiation from the heated plate to the surrounding environment at the temperature of the surrounding environment T surrounding. In reality, the radiometer is a tiny region of the surrounding environment at temperature. Next is a Lambert's casine law for light. According to the Lambert's law for diffuse radiation, the radiant intensity along a beam is precisely proportional to the cosine of the angle formed between the beam and a line perpendicular to the radiating surface. The equation is L angle equal to L0 cos angle. L0 is a radiant intensity in perpendicular direction to the surface. L angle is a radiant intensity at angle in respect to the normal direction. Lastly, Lambert's law of absorption. According to Lambert's law of absorption, the luminous intensity of light drops exponentially with the distance t that is traveled through an absorbing material with a linear absorption coefficient. The equation below calculates the light intensity of the beam striking the absorbing filter. The equation is LF equal to LO exponent negative t. LO is the light intensity of the beam, incident beam. LF, light intensity after crossing the filter. T, filter thickness, absorbing capacity of the filter material. Because of the material's light absorption, the light intensity is lower. The amount absorbed is determined by the filter thickness and the filter material's absorbing ability. In actuality, some of the light is reflected on the front surface of the filter and does not pass through it. When considering the absorption inside the filter, it is therefore required to identify this value of reflected light. This reflected loss, LR, must be included in the above equation, which is as follows: LF equals to LO minus LR exponent negative T.
Assalamualaikum and thank you to my fellow friend. Today I will present to you the experiment setup for heat radiation. A thermal radiation apparatus is placed on a flat table, which is this, and then the switch will be turned on as the temperature increase, shown on the temperature reading. The reading of the temperature will be stabilized at a certain amount. Then the radiometer reading is also observed as the temperature increases. The radiometer is covered by a rubber cover to prevent the heating of the radiometer. Also, the distance of the radiometer and the heat source is by a scale on the thread. The measurement of the distance will be using parallel to the eyes levels so that we can avoid the parallax error. Also, to avoid the inaccuracy of the radiometer reading, the experiment is start for the furthest to the nearest between the radiometer and the heat source. Then for the experiment procedure, for the test one, which is to show that the intensity of the radiation is varies as the fourth power the source temperature as stated in the Stefan-Boltzmann law. First, we connect one of the thermocouple of the target plate T1 to the service unit and place the plate on the bench to record the ambient temperature. Second, position the radiometer on the test thread at 800 mm from the heat source. Third, select the selector knob on heat transfer service unit to read the radiometer measurement. And then set the temperature to 250 Celsius by heater controller. Then we monitor the T4 reading on the heat transfer service unit. Fourth, when T4 value has stabilized, we move the radiometer to 300 mm from the heater plate. And the reading of the radiometer should start to rise when the value has stabilized. Then we record the T1, T4, the distance, and X, the radiometer reading, and R. Next, move the radiometer to 800mm from heated plate again, and then since we repeat the above procedure with increment of 50 Celsius from 250 to 400 Celsius. Then after that, we calculate the relationship between the Stefan-Boltzmann law and the collected reading of C given as factor of F. And for the test 2 is to demonstrate that the exchange of radiant heat energy from one surface to another is dependent upon their interconducting geometry. First, the apparatus folder is installed at 200mm from the heated surface. Then a radiometer is installed on the thread at 800mm from the heated surface. 400 Celsius is applied to the heaters. The T4 indicator reading is monitored on the transfer service unit. The third step is the radiometer position is moved to 100mm from the aperture position when T4 value has stabilized. The reading of the radiometer should start to rise. When the value has stabilized, T4, aperture width, and R are recorded. Fourth, the aperture plate is installed on the aperture holder and the width is adjusted to 5mm, and again T4, aperture width, and R are recorded when reading has stabilized. The gap with an increment of 5mm increment is increased, and the above procedure are repeated. And the area factor is calculated, and then the area factor against the aperture with millimeter graph it also will be plotted. That's all for me. Thank you.
A very good day. I am Nur Azira binti Herman Tung Ching Ho with ID number MA18232 will present about the result and calculation for two tests conducted in heat radiation topic. The first test is to show that the intensity of radiation varies as the fault power, the source temperature, as stated in Stefan-Boltzmann law. In the first investigation, 4 parameters can be calculated. The heat flux, angle, constant heat flux, and correction factor can be calculated by using equations stated in chapter basic equation previously. From calculation, the heat flux can be calculated by using the Stefan-Boltzmann law, which Stefan-Boltzmann constant will be multiplied with the temperature 4 to the power of 4 minus temperature 1 to the power of 4. Stefan-Boltzmann constant is 5.67 times 10 to the power of negative 8 W over m to the power of 2 K to the power of 4. Next is the calculation of angle, where angle will be r time multiplied with 50 over distance x. Then, corrected radiometer reading QR can be obtained by multiplying the heat flux with sine to the power of 2 times angle. Lastly, the calculation of correction factor C can be obtained by corrected radiometer reading QR divided with the radiometer reading R. So, the table shown tabulate all the data of calculation for test 1. Second test is to show that the exchange of radiant energy from one surface to another is dependent upon their interconnecting geometry. The variable parameter in this experiment is the width of aperture, while the constant parameter is the distance x. This experiment shows that the radiometer reading is dependent on the width of aperture, where in the increased value of aperture, the radiometer reading will be increasing too. Table shown the tabulation of data in this experiment too. So that is all from me. I'll pass the presentation to my friend. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz bin Maluki, MA18182. Okay, for my presentation, I will present for part discussion. Okay, for discussion number 1, what actually happened during the heat radiation process. The radiation occur when heat move as energy wave. Or the heated object transmit heat to colder object, and when heat wave strike a colder item, the molecule in the cooler object will accelerate, and when the molecule of an item accelerate, it will become hotter. Infrared wave are part of an energy wave spectrum known as an electromagnetic spectrum, like heat, X-ray, radio wave are example of energy that may move in wave. All these waves have a lot of energy in them. Next, we go to for discussion number 2. Okay, for discussion number 2 is what is the most significant point that can be deduced from a relationship between the Stefan-Boltzmann law and the collection radiation reading R. The Stefan-Boltzmann law describes how much energy the sun emits in relation The law also forecasts how much heat is radiated into space by the Earth. Meanwhile, the radiation reading were increasing as the temperature of black plate increased. This result showed that the black body was absorbing the heat emitted from the heat source, and some of the heat are transmitted through radiation. The result also showed that as the power input increased, the higher the temperature and radiometer. So next, we go for the discussion number 3. From graph 1, radiometer reading versus heater temperature. We can see that radiometer reading is directly proportional to the heater temperature. Meanwhile, for the graph 2, radiant energy versus width, we can see that radiant energy is directly proportional to width. As we can see, radiant energy was increasing because the width was increasing. So that's all from me. Thank you.
Assalamualaikum, my name is Ziti Afika, MA18226. So today I would like to present about the factor will affect the radiation process. There are 3 factors that will affect the radiation process. So the first one is the reflectivity of the ground surface. This shows how much of the light is reflected by the ground. The higher the reflectivity, the higher the radiation intensity. So the next one is the temperature of the atmosphere. Some heat is rejected to the atmosphere if the ambient temperature is lower than the radiating temperature. And lastly is the surface shape factor and propagation direction. The radiation losses are proportional to the emission when the emissivity of the surface or gas is taken into account. So next, we jump to the conclusions of this experiment. Radiation does not need any matter to transfer. It transfers in electromagnetic wave. Okay, after we conduct the experiment, it shows that the intensity of the radiometer depends on the distance of the radiometer and the heat source temperature, and also the size of aperture opening. So, if we look on the graph, radiometer reading and heater temperature, it finds that that the result is directly proportional. As the heater temperature increases, the radiometer reading will increase too. Besides, based on the graph of radiant energy versus the width of aperture opening, it found that the graph is directly proportional. Okay, the gradient energy is dependent on the width of the aperture opening. As the width of the aperture opening increases, the gradient energy will increase too. And then, when the temperature of the heater is increased, the heat flux value will increase as well. This is because when the heater temperature rises, the black body emits more radiations with a longer wavelength. And then, lastly, based on the principles of the inverse square law, the value of radiations flowing into an area is inversely proportional to the distance between the area and from the energy sources. So that's all from us. Thank you.